So as Alina already told you, there are tones, and now these can also stand in some relation to each other, which brings us then to intervals. And I think it's easier to understand intervals with first understanding the pitch space they are located in. And in our case, that brings us to the Western pitch space. It's divided in semitones and whole tones, where a semitone is the smallest entity of a 12-tone scale. And a 12-tone scale refers to the number of semitones. Here on the right you can see the C and the C sharp, and in between those notes there is a semitone. Another thing is the whole tone, which is then constructed of two semitones, and here on the right you can also see an example with the F and the G, and in between those two is also a whole tone. But there are also other pitch spaces worldwide and also in modern music, and these can include also quarter tones and even eighth tones, for example in Arabic, Indian music, or in other modern classical music. And now I'm going to tell you something about basic intervals. And for those, you only count the staff positions, and in this example you start at the C and you have to include the first and the last note while counting. So you count the C and then the space above and then the line above and then again where the F is. So you have 4 steps, and that leads to the conclusion that this interval is a fourth. Other basic intervals are the unison, second, third, fourth, fifth, sixth, seventh, and the octave. There are also bigger intervals than the octave, like the 9th and the 10th, but they are not as commonly used for describing. So that brings us to the specific intervals, which are a more detailed representation of the intervals. And they are defined by the number of semitones that then defines the interval. And to understand that better, I have an example for you on the left with this E and the G sharp. And to better determine which interval it is, I have a keyboard for you, because every key describes a semitone, and it's easier to count how many semitones are in between those two notes. But you have to also include the black keys while counting. And on the right I have a table which shows you how many semitones make up which interval. And there you can see that there are more detailed versions of the basic intervals. For example, there is not only a fourth, but an augmented fourth and also the perfect fourth. And another example would be here the minor and the major sixth. And in this example, you have the E, and then you can start counting on the keyboard at the E, and then you'll go to the F and the F sharp and the G and the G sharp, and those are 4 semitones. And then you can have a look at the table, and this tells us that this interval is a major third. And now we're going to probably get some more intuition for the intervals with consonant and dissonant intervals. And first I'm going to explain you the different characteristics of those two. The consonant intervals are described as pleasant and also acceptable when you hear them, while the dissonant sound quite harsh, and you can really hear the friction between the two notes, which then make up this interval. And also the consonant is quite a nice interval as a final tone in a piece, while the dissonant kind of wishes for resolving into another consonant interval. And now I have some examples for you. A perfect fifth versus a tritone, and you can guess which one is a consonant and which one is a dissonant interval. And then I also have another example, a major third versus a major seventh. And I think you can also tell which one is a consonant here and which one is a dissonant. And in the end, I also have a mathematical description for you, because you can also define those intervals with frequency ratio. And with frequency, I really mean the physical notion of frequency. And first I have an example of the octave. There you have the A4 and A3. And the A4 has a frequency of 440 Hz, while the A3 has only the half frequency, 220 Hz, which is the deeper note. And there you can see quite good that there's a ratio of 2 to 1 between those two tones. Another example would be the major third between the C4 and E4. And there you can also see that there is a ratio of 5 to 4. Generally, you can say that consonant ratios have smaller integers, while dissonant ratios have higher integers. For example, 16th, 15th for minor second. And I talked about the basic intervals and then about some more specific intervals, but there's even a finer determination for the distance between two sounds, which are cents. When you have one semitone, you can divide this semitone into 100 cents. So, if you can do the math, 1 octave equals 1200 cents. And there is also a formula to really determine the cents for a specific interval. And it is I equals the log to the base of 2 from Q times the octave. And in this formula, Q means the frequency ratio of an interval. So here I gave you the example for 1/5, where you just plug in 3 halves, which is the ratio of 1/5. And if you put that into your calculator, you have the number of cents of this interval.